Let's do a quick recap of angle of elevation and angle of depression. The angle of elevation is the angle that's formed between the horizontal line of sight and the inclined line of sight when a person is looking up. The angle of depression is formed between the horizontal line of sight and the inclined line of sight when a person is looking down. Looking at this diagram, you can see where the angle of elevation and where the angle of depression would usually be when the person is looking up and when they are looking down. This is the first example. Pause the video and copy the question. Angle of elevation and depression example 1. So the angle of elevation of the top of a vertical tree from a man standing on a level ground is 25 meters from the base of the tree is 38.5 degrees. Calculate the height of the tree correct to the nearest meter. So you have a man standing on the horizontal ground and he's looking up at the top of a tree. The distance from the base of the tree and the man is 25 meters, and then the angle of elevation formed from the man looking up to the top of the tree is 38.5 degrees. They want you to find the height of the tree. Now, this is a graphical representation of the question. Now, looking at this, we could extract our right angle triangle. And extracting the triangle, we have our horizontal line, which is going to be 25 meters, which is the ground. You have the line, which is the inclined line of sight, that forms the angle of elevation. And then you have h, which is the height of the tree. So we have to find the length of this side. Now, when we are working with right angle triangles and we have to find the missing side, we know that we have to use our trig ratios, and our trig ratios are sine, cos, and tan. And I've just written SOHCAHTOA here so that you can remember SOH, CAH, and TOA. Now, if I'm working with this angle, then this becomes my opposite side. And the side that is below or next to me is my adjacent side. So the ratio that deals with opposite and adjacent is tan. So tan theta is equals to opposite over adjacent. Tan theta is our angle, which is 38.5, is equals to our opposite side, which is h, over our adjacent side, which is 25 meters. We put this over 1 and then we cross multiply. H times 1 is going to give me h, and 25 times h times 1 is going to give me h, and 25 times tan 38.5 is going to give me 25 tan 38.5. Put 25 tan 38.5 into the calculator. You're going to get 19.88. The one decimal place is 19.9 cm. This is example 2. Pause the video and copy the question. Example 2. So a girl 1 meter in height standing on top of a vertical building 45 meters high sees a car some distance away when the angle of depression is 55 degrees. What is the distance? What distance is the car from the base of the building? So the building is 45 meters. She is 1 meter standing on top of the building. And when she's looking down at the car, the angle of depression formed is 55 degrees. Remember that the angle of depression is between the horizontal line of sight and the inclined line of sight. So that would be up here. Taking all of this and extracting it to a triangle, we have the girl height and the building height, which come together and give me 46 meters. The angle of depression is up here, and they want you to find the distance. Now, in order for us to work this, we must know an interior angle. So taking into consideration alternate angles, or what we call Z angles, this angle is formed in a Z. That would be this line coming this way, the inclined line of sight, and the horizontal line, which is the ground. That means the angle formed here and the angle formed here is the same. So if this is 55, then this is also 55 degrees. Remember, Z angle, let me just write it here, alternate. So in your own time, you're going to research what is alternate angles. You have co-interior angle and you have corresponding angles. Now, we know this angle here, right? So then if we're working with this angle, this becomes my opposite side and this becomes the adjacent side. Looking at our three trig ratios, opposite and adjacent, we're working with tan. So tan theta is equals to opposite over adjacent. Tan 55 is equals to the opposite side, which is 46, over the adjacent side, which is d. We put this over 1 and then we cross multiply. So d times tan 55 is going to give me d tan 55 is equals to 46 times 1 is going to give me 46. I want the value of d, so I divide here by tan 55 and I divide here by tan 55. This and this cancel out. The distance is equal, so we use our calculator. 46 divided by tan 55, and that's going to give me 32.21 meters. Round it off to one decimal place, we have 32.2 meters. So the distance of the car from the base of the building is 32.2 meters. This is example 3. Pause the video and copy the question. Third example. A surveyor stands 100 meters from the base of a tower on which an aerial stands. He measured the angle of elevation to the top and the bottom of the aerial as 55 and 51 degrees respectively. Calculate the height of the aerial. You have the tower, the aerial is an antenna. So the surveyor is looking at the bottom of the aerial and the top of the aerial. And the angle of elevation to the bottom is 51 degrees and to the top is 55 degrees. Taking this into consideration, we extract our triangle. We have a right angle triangle with two angles of elevation, one being 51 and one being 55. So if we're to work with the top of the tower, sorry, the top of the aerial, if we're to work with the top of the aerial, then we're looking at the height, all of this, and we have to take the 55-degree angle into consideration. Now, we're going to go to the top, and if I'm working with 55, then this becomes the opposite side, and this is my adjacent side. So again, we're working with tan. So tan theta is equals to opposite over adjacent. Tan 55 is equal to the opposite side, which we don't know. Let's call it t to be the top of the aerial over the adjacent side, which is 100 meters. Put this over 1 and then we cross multiply. So this is going to be 100 times tan and t times 1. T times 1 is going to give me t, and this would be 100 tan 55. T is going to equals to, use our calculator, 100 tan 55, and that's going to give me 142.81 meters. So this is the height to the top of the aerial. Now let's work with the bottom of the aerial. Again, the bottom of the aerial now would become this piece, right? So let's call this B, and we're working with 51 degrees. If I'm standing here, then B becomes my opposite side, and this is again the adjacent side, right? So we're working with tan. So tan theta is equals to opposite over adjacent. Tan, our theta now becomes 51 because we're working with this triangle. Tan 51 is equals to the opposite side, which is B, over the adjacent, which is 100 meters. Put this over 1 and then we cross multiply. B times 1 is going to give me B is equals to 100 tan 51. B is equals to, let's use our calculator, 100 tan 51 and 100 tan 51, and that's going to give me 123.49 meters. Now if we found the bottom to be 123 and we found the top to be 142, then to find the distance, to find the height, sorry, of the aerial, we just have to subtract the bottom from the top. So the actual height of the aerial is going to be 142.81 meters, subtract 123.49 meters, and that's going to give me 142.81 subtract 123.49, 19.32 meters. So the height of the aerial is 19.32 meters. This example 4, pause the video and copy the question. Example. So from a coastal lookout point P, 100 meters above the sea, a sailor sights two boats A and B in the same direction. The angle of depression of the two boats are 15 and 23 degrees respectively. Calculate the distance between the two boats. Now this is the lookout point, and he saw two boats, and remember the angle of depression is between the inclined line of sight and the horizontal line of sight. So from this diagram we extract our right angle triangle. Now looking at it, we have the angle of depression to boat A is 15 degrees, but in order to solve we need angles inside our triangle, right? So again, alternate angle, which is our Z angle, makes this angle also 15 degrees, and similarly with this one, the same Z angle makes this angle here 23 degrees, right? So now we can find the distance from there to A, and we can also find the distance from here to B. And when we find the two, we subtract them from one another and we would find the distance between the two boats. So now let's start with A, boat A. So if we're using this angle, we know this is our opposite side. So we have to find our adjacent side. Opposite and adjacent again is tan. So tan theta is equals to opposite over adjacent. Tan, we're working with A, so the angle is 15 degrees. Tan 15 is equals to the opposite side, which is 100, divided by the adjacent side, which let's call it A. Put this over 1 and then we cross multiply. We would get A tan 15 is equals to 100. We want the value of A, so we divide by tan 15 and we divide here by tan 15. So A is equals to this, and this cancel out. 100 divided by tan 15, that's going to give me 373.21 meters. Now let's look at boat B, which is in here. Now we're using the 23-degree angle. Again, this is our opposite side and this is our adjacent side. So opposite and adjacent is tan. So tan theta is equals to opposite over adjacent. Tan 23 is equals to the opposite side, which is 100, over the adjacent side, which is B. Put this over 1 and then we cross multiply. We would have B tan 23 is equals to 100. We want B, so we divide by tan 23 and we divide here by tan 23. This and this goes. So B is equals to 100 divided by tan 23, 100 divided by tan 23, and that's going to give me 235.58. Now the distance between both A and both B, that would be, you're subtracting B from A, so it would be A subtract B. A is 373.21 meters, subtract B, which is 235.58 meters. Subtracting the 2, I would have 373.21 subtract 235.58, and that's going to give me 137.63 meters. and has a distance between both A and both B.